last week we talked about multiplying rational expressions. And the word rational means what?
Fractional.
Okay, so we talked about multiplying fractional expressions. So just as a review, if I have like 2 over 3 times 7 over 2, what can I do with that? Okay, I can multiply the tops, multiply the bottoms, and reduce, or I can go ahead from the beginning and cancel out my 2's. And either way, I'm going to end up with 7 over 3. So to address some questions that we have had over like the previous 2 days of teaching this, one of the questions that I had was, if I had something like this, can I cancel out these 2's if they're in the same fraction? Yes, they don't have to be in opposite fractions in order for things to cancel out. As long as one's on the numerator and one's in the denominator, they're going to cancel. Okay? They don't have to be in opposite fractions. They just have to be one in the numerator, one in the denominator. They have to be paired up. So these 2's would still cancel, and you would still be left with 7 over 3. The next question that I saw a lot of was if I had 2 over 3 times 7 over 4, times 7 over 5, times 2 over 9, it was a terrible 9, times 3 over 2. When people started canceling out things, obviously, hopefully you can tell the 3's cancel. The question was then how many 2's canceled. People were wanting to cancel out all the 2's on top with all the 2's on bottom. You can't do that because you have to be able to pair them up. So I can only cancel out how many pairs of 2's. One pair because I only have 1 2 in the denominator. So this would end up with an answer of 14 over 45. And can that reduce? No. Check in here. Can you have reduced any of this in here? No. So you can't reduce anything on the answer in either. Okay? So if I gave you the problem 3 over 7 divided by 5 over 2. Dividing by a fraction is the same thing as multiplying by the reciprocal. And you have to reciprocate the second fraction, the one that you're dividing by. That's the one that ends up getting flipped. So it's the same thing as multiplying by 2 over 5. Can I do any canceling out in this problem? Nope. So I just multiply. What's 3 times 2? And 7 times 5? So my answer would be 6 over 35. This is what we're focusing on today, is the division. So it doesn't really change the process, but it means that the first thing we have to do is, because I can't divide by a fraction, instead I have to multiply by its reciprocal. So the first thing we have to do is to flip our fraction. All right, so we're starting on page 532 of 10.2. And we are going to be working with this division problem. So we have 6x divided by 3x minus 30 divided by the fraction 9x squared minus 27x minus 36 over x squared minus 10x. So instead of dividing by all of this over here on the right side, what can we do instead? We can multiply by its reciprocal. So we're going to do 6x over 3x minus 30 times x squared minus 10x over 9x squared minus 27x minus 36. So now I need to multiply. Well, this is just like everything else we did before spring break, so we need to figure out our factors. Okay, can we factor 6x? No, so that's going to stay the same. So we're still going to have 6x. Over, can I factor 3x minus 30? What can you do? Take out a 3. Okay, when we take out the 3, it's not poof, it disappears. Where does the 3 go? Outside the parentheses, because we're factoring it out. So that's something else I've seen happen a lot, is you'll factor these things out and then they just disappear. Okay, we're not magicians, we're mathematicians. Things don't just go away. And then times, okay, can I factor x squared minus 10x? I can take out an x. So if I take out that x, I'm left with x minus 10, okay? And then can I factor 9x squared minus 27x minus 36? Yes. What can I do first? Take out a 9. There's a GCF. So I can factor out a 9, and then I'm left with x squared minus 3x minus 4. So again, let's see, we can rewrite this. 6x over 3 times x minus 10 times x minus 10 divided by 9 times, and you said that x squared minus 3x minus 4 factors into x minus 4 times x minus 1. Plus 1, sorry. Thank you. There we go. Okay. So now that I've got all of my factors figured out, can I cancel anything out? Yes. What cancels? Okay, and they only cancel, remember, if there's one thing, if there's a pair on top and bottom. So those cancel. Anything else cancel? Check again. Or any other math we can do?
We can multiply by 3.
You can multiply 3 and 9. I wouldn't.
The 6 and the 9.
Or?
The 6x and 10.
Which x? Oh, you could multiply these two, yes.
The 6 and the 3.
I would do some division here because you have a 6 divided by a 3. And 6 divided by 3 is 2. So technically you reduced a fraction. Is there anything else we can do to that then?
Divide the factors by number from the line.
Why not? So anything else we can do to this problem? Yes, no? I don't think so. Okay, so numerator, what's left? 2x squared divided by 9 times x minus 4 times x plus 1. Okay, and then how do I find the rest of my answer? Everything that was in the denominator, we have to figure out the excluded values. Okay, as long as it has an x. So this is where things get a little bit tricky. So we'll get to that part in a second. But we look at our denominator. So we look at 3 times x minus 10. That was the denominator. What would be my excluded value from that one? Positive 10. Okay, why doesn't 3 provide an excluded value? There's no x with it. The only thing you get excluded values from, excluded values, are from your x's. Okay, so it's whatever, because you have to remember you're setting that equal to 0, and there's no way that 3 can ever be equal to 0. All right, then we have another denominator over here. We have 9 times x minus 4 times x plus 1. So how many excluded values is that one going to give me? 2. What's the first one? And the second one? Okay. There's one other place I have to look. The original denominator. What was my original denominator? The x squared minus 10x, which was x times x minus 10. This is where the division part is. There's one extra thing. So first of all, the division really has 2 extra steps in it. The first thing you have to do is you have to flip your fraction so that it turns into a multiplication problem. The second thing that makes division additional to, or an extra, I guess you could say, from the multiplication is that you have to consider, again, anything that at any point in time was ever in the denominator. There's been 3 different things that have been in the denominator because we've moved stuff around. So x times x minus 10 was also in the denominator, which gives me how many excluded values there? Okay, so the first excluded value, x gives me an excluded value of what? 0. And then I get one from x minus 10, but what is the excluded value here? It's 10, which I already have, so I don't have to write it twice. So this would be my final answer to this problem. Okay, so problem 4 at the bottom of this page. We have x plus 11 divided by 4x. divided by the fraction 2x plus 6 over x squared plus 2x minus 3. So what's the first thing we need to do? Flip the second one. So we're going to reciprocate the 2x plus 6 over x squared plus 2x minus 3. So still have x plus 11 over 4x times x squared plus 2x minus 3 over 2x plus 6. And we like multiplication problems. Well, as much as we can like math problems, we like those. They're easy. What do we do now? We can factor out the 2 in the denominator. Can I factor anything in the x plus 11 over 4x? No. So we're going to leave that alone. So we'll still have x plus 11 divided by 4x multiplied by, okay, can I factor x squared plus 2x minus 3? Yes. Into,
X plus 3, x minus 1.
okay. Divided by, and Joe, I heard you say we could factor the 2 out of 2x plus 6. So it's a GCF, so 2 times x plus 3. Whew. Okay. All right, so we've done the reciprocal, we've factored. What else can we do? Cancel out what?
X plus 3.
Okay, my x plus 3's will cancel. Anything else cancel?
No.
Okay, so then putting it all back together, my final answer would be x plus 11 times x minus 1 divided by 8x. If your denominator is easy to multiply together, like 4x times 2, multiply it together. If it can't be multiplied easily, like x plus 11 times x minus 1, what would you have to do to multiply that? Foil. So not difficult, but a lot more work. Like there's no reason to multiply that back out to foil that, but go ahead and multiply 4x times 2 because that's really simple. It's just 4 times 2. And now I need to figure out my excluded values. So we start with our denominators. So my first denominator is 4x. So it's going to give me an excluded value of what? 0. Yeah, if it's just 4x, it's going to give you an excluded value of 0. Anytime it's just like x. X can have a coefficient, but x can't have like a constant added or subtracted to it. Yes.
So then, going back to the other question,
Mm-hmm.
would you be able to, what about 6x? Is that?
Are you talking about here? Yeah, that would give you an excluded value of 0, but that was in the numerator, and we don't worry about the numerators.
Oh, okay.
Except for this numerator. And why do we worry about this one?
Because we got flipped.
It got flipped, so originally it was in the denominator. So anything that's ever in the denominator, that's what we pay attention to. So that's why we didn't get one from there, from that one. But yes, if that had been the denominator, it would have been 0. Okay? All right, so what else is going to give me excluded values? Okay, we've got a couple. Let's see. So we have 2 times x plus 3 here is going to give me an excluded value of -3. And what else? Okay, so this numerator will also give me an excluded value, again, because that numerator originally was in the denominator, because we flipped it. And that's going to give me, technically it gives me 2. What's the first one? -3, which we already have that one, so we don't need to worry about it. What about x minus 1? What's that excluded value? 1. So that would be my final answer, is x plus 11 times x minus 1 over 8x. But x cannot be 0, -3, or 1. What happens graphically at those 3 values, 0, -3, and 1? Poles or vertical asymptotes, one of the two. So which one's going to give you a whole? The -3, because that's the one that canceled. And the other two are going to give you vertical asymptotes. Yes, everything from this point forward or from the rest of 10 is going to have an equal sign in it. So, and we're solving rational equations, then we're solving fractional equations. So let me ask you, how do you solve that? You do the butterfly. You cross, multiply, and divide. Okay, so I'm going to actually write out mathematically step by step what you're doing. So first thing you're doing is x times 4. What is x times 4? 4. And you always multiply from bottom to top. Okay, that's important. You always multiply from the bottom to top. And then you need to multiply 12 times 2, which is 24. That's where your cross multiply part comes in. And then the next part, when you say cross multiply, it's cross multiply and then divide. Why do I divide? You're trying to figure out what x is. You're trying to get rid of that 4. So mathematically, you divide both sides by 4, and you get x equals 6. It's essentially what we're doing today. Now our problems, are going to be way more complicated, but that's really what it boils down to. Yes, ma'am. Yes, that's what we're going to do. Okay, so we are looking at page. So if I ask you to solve this, I have two fractions, which as much as you hate fractions, having two fractions is better than having one. It really is. So if it's an equation, it's technically a proportion. I can use the butterfly. I can cross multiply and divide. So I'm not actually going to multiply things. We're just going to write them out. So if I multiplied 15x plus 60 times 5, then I would have 5 times 15x plus 60. And remember, it doesn't matter what order you multiply in, you still get the same answer. That's the... Which property is that one? All right, so then I need to multiply 12x times x squared plus 9x plus 20. Now, you could actually distribute these out, okay? But I wouldn't, because that's way more work on yourself than you need to do. Because guess what we're about to do with each of these? Yes, we're going to factor them. So if we distribute them, then we're really causing more work for ourselves. So I have these two awful looking things on both sides that I do need to factor. Can I factor x squared plus 9x plus 20? Yes. Okay. We'll say with possibly. That's a good answer. Okay. We can, and how does it factor?
X plus 4, x plus 5.
Okay. So I still have my 12x. And then this part factors into x plus 4 and x plus 5 equals, clearly I could not factor 5. Hopefully you all know that. Can I factor 15x plus 60?
Yes.
How does that factor?
15.
Okay, so I factor out a 15, and I'm left with x plus 4. Mathematically, what happens here with this 5 and this 15? You multiply them together. The reason is because 5 was originally multiplied by 15 times x plus 60. I just changed the way that 15 times x plus 60 looked, so these two are still, in fact, multiplied. So just to make it look a little bit better, I'm still not distributing anything in. I have 12x times x plus 4 times x plus 5 equals 75 times x plus 4. Okay, and I realize this looks awful, but we need to factor it all out. Why do we need to factor it all out? See if you can cancel anything out. Can I?
Yes. X plus 4.
Why?
Because you subtract both sides, it'll cancel.
Not subtract them.
Divide.
You divide them from both sides. Okay, so there's a rule in math that you guys understand really well, kind of. A long time ago, you learned that if you do something to one side of the equation, what I need you to understand is that means that you can do whatever you want to one side of the equation as long as you do the exact same thing to the other. So if you decided that you wanted to add 1,000,000 to the left side of the equation, cool, you can do that. But if you do that, what else do you have to do? You have to multiply by the other. So you can literally do anything you want. I could multiply both sides of this equation by 2. I could. Wouldn't help me a whole lot. But the reason I say that is because that's why these x plus 4s cancel, is because, cool, I can divide this by x plus 4 if I want to. Why not? I can do whatever I want. But if I did it to the right side, what do I have to do? So I have to divide the left side by x plus 4. And why does that benefit me in this problem? They cancel each other out. So my problem gets smaller. So now my problem is 12x times x plus 5 equals 75. It does look so much better. So much better. Okay, thoughts?
That was a lot easier than I thought.
Can you, like, would you multiply the 12 into the x plus 5?
Okay. So Joe asked if we could distribute. Sure, why not? Let's distribute. So 12 times x would be, 12x times x would be 12x squared. And 12x times 5 would be, okay. And that still equals 75. Yeah.
We subtract 75 and then factor it out.
Would that work?
No, it's fine.
Yeah, and then you set it
And then
equal
you
to
would-
0.
I don't know.
Is that what you're asking about doing? Okay. Can you do anything with that?
No,
Can
possibly.
you simplify it? Like UCF?
Well, then
right?
you would like distribute that back over.
You can factor it out,
Okay, so there's a GCF. All right. The GCF I keep hearing is 3. So if I take that out, I'm left with 3 times squared plus 38. Oh, thanks, guys. Cool.
Oh,
Minus 25. Okay.
let's see.
What are we doing with this?
We're solving. Remember, the whole thing was to solve for x.
Is this the
But why did
Oh,
we
this
do
is one.
this?
Oh.
Do I? No? Maybe. I'm waiting for y'all to figure this out.
I don't think it should be divided. What if we would, okay, what if we just go back to 12x plus 5 and just divided it by 12?
We do something with just that.
Hold on. I've got 2 different questions coming. So what was your question, Kaylee?
Can we still just like do it from where it's
From here?
on the outside of that?
And no, you can't. Okay. What was your question, Joe?
You should just say that divided by 12.
No, she was asking if we could solve it from this point.
Oh.
Why
I
not?
was gonna say, could you like divide the 12?
It's not equal to 0. What kind of problem is this now? What kind of problem is it now?
Quadratic.
It's a quadratic. And the only way to solve quadratics is if they equal 0. And how do we solve quadratic equations? Quadratic formula, that's an option. What else is an option? Factoring. Completing the square. I'm not going to make complete the square. I can group if I'm factoring. Okay, this does factor, by the way. But could you use quadratic formula on this problem? So could you go back then to this step right here, the yellow part, and use quadratic formula?
Yeah.
You could.
That sounds good.
You can. It works. Okay? Or you can factor. This does factor. It factors into, oh gosh, 100, 10, 10, 2, 5, 2, 5, negative. No, that doesn't work. Sorry, that doesn't work. Okay, so it doesn't factor, so that idea is out. That's okay. So now we have to use the quadratic formula. Yay! What is quadratic formula?
Negative b plus or minus the square root of b squared minus 4 all over 2a.
Okay. This is where I'm stopping for today.
Yeah.